Let's take a look at Leetcode question number 100 called as same tree. In this question, we will be given two different binary trees root nodes, namely P and Q, and we have to return true if both the trees are same and false otherwise. So, how to identify whether both the trees are same or not? So let us take first example. The root is 1 for P and for Q also root is 1, so good enough. Let's go to the left subtree. Left subtree node value is 2. Again, let's go to left hand side for this one. Left subtree node value is 2 and the right subtree value node is 3 over here. Same is for this one. So this says result true. Let's take example number 2. In example number 2, the tree may look similar because it has the same values. But if you see for the P tree, the left node is 2 and for Q, the right node is 2. So these are two different trees, not the same ones. Let's take example number 3. In example number 3, we have same value nodes, right? 2 1 1 over here also it is 2 1 1, right? But in first tree, that is P, if you traverse you get 2. If you traverse in order you get 2 then 1 and 1, and in this tree Q you get 1 1 and 2, so the tree is different. So how to identify whether this tree are same or not? So there are two different ways to do is one is iterative and one is recursive. The first statement would be that if P node is equal to null and Q is equal to null, then we say return true. If both of them are null, then yes, we are good. If either of them is null, so let's say if either of them is null, or then we say it's false. And if P dot val is not equal to Q dot val, then also you return false. These are the three lines base condition for our recursion. Now let us recurse. We will say return is the same tree P dot val comma P dot left comma Q dot left and is same tree P dot right comma P dot right comma Q dot right, and that's it. This is all there is. So if both the nodes are null, then we return true. If either of them is null, then we return false. And if both the values are not same, then we return false. And then we iterate on the left subtree and we iterate on the right subtree. Let us submit this and see what happens. So this worked out fine. Now let us see the time and space complexity for the recursive one. So let me copy this, comment it, and I will say is same tree recursive, make it private, okay. And let's say time complexity. The time complexity would be O of n, as we are traversing all nodes exactly once. Space complexity is again interesting. Space complexity may be of log n if tree is balanced tree, or it will be O of n if it is skewed tree or unbalanced tree, because if it is an unbalanced tree we will end up adding all the nodes to it. So this is how you can solve the problem using recursion, and the time complexity will be O of n and log n will be space time complexity if the tree is balanced, or it will be O of n if it is an unbalanced tree. This is it on the recursion. Now let us handle this same problem using iterative approach. If you are doing an iterative approach, then we'll have to use some form of additional data structure to hold the elements. Let's take a look at that now. In this approach, what we will do is we'll use Deque interface, and the implementation will be linked list class. So we can write it like this, and linked list allows us to add null values. So we can do something like this: add p and add q. Even though they are null, it's completely fine to add them. And while q is not empty, what we can do is we can just remove the first values out like this. So q dot pull and q dot pull. Now let us write the similar conditions that we wrote in recursive way. So p is equal to null and q is equal to null. Then you just continue with the loop. No need to do anything. You don't need to add any values into the queue. Now p is equal to null or q is equal to null, then we return false. This means that either of them is null but not both of them. And if p dot well is not equal to q dot well, then also return false. Now let us add all the values to it. So first add left values. So p dot left, q dot add, p dot left, q dot left, p dot right, and q dot right. That's it. And once this queue is empty, we know this condition has not been executed. This condition was not, these two conditions were not executed. So over here we can just go ahead and say return true. This should do it. Okay, let me do this. So this worked. Now let us take a look at time and space complexity. So again, time and space complexity for iterative way is also same as recursive.